Good morning and welcome to today's episode of Code and Coffee. My name is Brian Selby. I'm your host here, Code and Coffee. Thank you for tuning in to the live broadcast. If you're listening via pre-recorded session, thank you for watching. We really appreciate you watching the show today. We're going to be bringing you some demonstration on how to model a fairly simple two-story project. When I say simple, I mean we're talking about basically a box with a detached garage. So we're not modeling garages, we're just modeling the house, two different floors, two different zones. So before we begin, I'd like to thank our sponsors, EnergyCodeAce.com. If you haven't been to EnergyCodeAce.com, which I'm sure most of you have by now, we offer lots of tools, resources, training opportunities. This is brought to you free on behalf of the statewide Codes and Standards team, which is the investor-owned utilities, through the auspices of the CPUC. So ratepayer funds that the utilities collect go towards increasing compliance with the energy code. So very special thank you to our Energy Code ACE Codes and Standards team for this opportunity. So we appreciate your liking and sharing this channel with your friends and other people in your office. So without further ado, let's get into our introduction here. So now we get a little bit of video. So hi everybody. This is your first time to the Code and Coffee live broadcast. This is just a real world demonstration of how I model projects. I'm not claiming to be the best or do it perfectly. This is just the way I do it, and hopefully this helps you in your work, either validate what you're currently doing or maybe offer some opportunity to improve efficiency in doing takeoffs or data input, or maybe you might learn something new. So thank you for hanging out with me. So our case study today, our project is a simple two-story residential single-family home. So we're going to be going through we're just going to do a real basic assessment. Pretty much I gave you the assessment there. Two-story home. I'll go through a few things with you. We're going to be modeling this project in EnergyPro, so doing the takeoffs using Bluebeam. I think our software versions are a little bit outdated. Maybe not. I know EnergyPro is just about ready to release a new version, so that's not available yet, and as soon as that is available, I'll be posting some videos on some of the features on how that's used. So good. If you have any questions, please feel free to put those questions in the chat window. On my headset here, I have my producer Lindsay and my tech manager Zach that are keeping me on track here. So we'll try to do this in under an hour, and it might get a little bit fast paced. So hold on here. Just for those of you who have been on the show before, got a new camera for the over the shoulder shot. So hopefully it's a little bit better quality. So we're going to take a look at our project here. This project is it's in a rural area. If anybody is familiar with Pine Mountain Lake in Groveland, California, let's hear it for all of those who know where Groveland, California is. Anyways, so we've got a site plan here. This is developed by a friend of mine, designer Rob Keith Designs up in Sonora, so my hometown. Anyways, we can see the front of the house here faces kind of northeast direction. Let's take a look at our floor plan. So fairly sizable project. I've done a little pre-work on this to save some time, so you can see the blue outline, the area we've already done. So the first floor is a little over almost 1,750 square feet. It's detached from the garage, so we're not worrying about modeling the garage today. Our second floor, let me hit the wrong button there. Our second floor is about 1,650 square feet. Now, there are no openings to below. So we're modeling the full square footage of above. Today we're not going to be modeling overhangs. That's something that we covered in a previous episode. So we may come back and do that on another episode again. But for the most part, we're just modeling this just as is here. Pretty sizable house. So ambitious project today to get this done in an hour. So I'm going to hurry up through this assessment. You can see that we've got a hipped roof for the most part. We got porch that wraps around a lot of the first story there. We've got some overhangs and decks, things like that that we could take advantage of. Something unique that we haven't done on this show yet is a raised foundation. You can see we've got raised floor. So the designer's calling out the insulation of the floor. We've got a 9-foot plate on the first floor, R21 cavity insulation in the 2x6 wood frame walls. We've got an 8-foot plate height on the second floor and a vented attic here. So I think that's enough information to get going. So anybody have any questions, please feel free to type away. But I'm going to get started on my takeoffs. So most of you are familiar with my takeoff method. I'm going to go to my over-the-shoulder shot here. I like using just a standard quad paper. Some people do their takeoffs in their PDF software. If you have a CAD file, like an AutoCAD DWG file, it's nice to do takeoffs on that. But I just use an old, simple, analog method for doing my takeoffs. And today I'm going to be using my manual calculator. I've got a screenshot calculator for doing some of the math, but for today's purposes, I'm just going to do it with this one. So, all right, without further ado, a couple things to remember here. We've got, first we need to get our orientation. So the front of the house is kind of facing northeast. I'm going to go to my measure tools. I'm going to call out a angle. Go to this one. So if you're new to this software, I use Bluebeam. Bluebeam's a great piece of software. It does cost to get a subscription to this. I think it's a couple $100. So my front orientation is, I want to round that to 46 degrees. So front, and I like to go around just to label the rest of them. Just add 90 degrees to that so that I know that everything is input correctly into the software. So my left orientation, I go clockwise. Start with the front, go clockwise. 136 degrees my left. My rear elevation, or my rear orientation, is 226 degrees, and my right orientation is 316 degrees. Front, left, back, right, all in order there. Okay. As far as my project information, I've kind of stripped off some of this info just to keep this project owner off the record here, but it is in Pine Mountain Lake. This is Zone 12, Climate Zone 12. It's right on the verge of good above Pine Mountain Lake. You're in Climate Zone 16, but for today's purposes, we're going to model this in Climate Zone 12, CZ12, and that's pretty much it for our general information. Let's start taking a look at getting our areas. So as you can see, I've gone ahead and defined what my perimeter or my area is. So 1,747 square feet for the first floor. 1,747. The second floor is 1,647. So 100 square foot difference. And you'll see where that 100 square foot is here when I go back to the first floor. There's a bit of a pop out over here that does not continue up to the second floor. So it has a shed on it. We'll take a look at that when we get into modeling that assembly here shortly. So, okay, we got our areas. We're not worrying about the garage because it's detached. I'm going to go ahead and start with my wall areas, my front wall. So we have a 60-foot overall width here. So the plate height is 9 feet, but because this is a raised floor, I'm going to add another 6 inches to cover that distance between the subfloor and the bottom of that insulation. R19 insulation nominally about 6 inches, so I'm going to call that wall height 9.5 feet. So if you're following along with me, 60 times 9.5 gives me 570 square feet. Looks like we lost our stream here for a second. So yeah, looks like we're back. Okay. Well, if you're experiencing some choppiness in the stream, apologize for that. Looks like it's just a little bit choppy. So, all right, we're going to work our way around for our walls. Since this is pretty much a box, we don't have to worry about bays, angles, anything like that. We're just going to go around and figure out what our left side is. This is, all right, I'm going to go to the right side because that dimension is a little cleaner over here. 32 feet, 9.5 times. So my left wall is 304 square feet. My back wall is the same as the front wall. There's no difference. It's 570. Likewise, my right wall is the same as my left wall, 304 square feet. Starting with our windows here. So we've got the first floor. I'm going to go through and do the first floor wall areas, window areas, and then we're going to jump to the second floor and take care of that. So looks like we got a lot of windows here in the front. So I'm going to start with the front right corner, work my way left and go clockwise around the building. So window 1 is a 3050, which is 15 square feet. Window 2, same thing. Window 3 is a 2650, so that's what, 12.5 square feet. I usually go to the nearest decimal point, a single decimal point. Anything beyond that, I think we're kind of splitting hairs. I usually round up to, if it's 12.67, I'll probably go to 12.7. So just a heads up there. Let's take a look at the front elevation, because those doors don't look like they're solid doors. So we've got a Halflight door. So the standards say if more than 50% of the door is fenestration or is window, then the whole door is fenestration. So I'm going to draw a box roughly about 2 inches bigger than the opening, and it's 9.2 square feet. So that's less than half of the door. So if the door's 20 square feet. So what I'm going to do is do the lights on the door separately from the door. So I'm going to call that Halflight 9.2, and we'll have 2 of those. And the doors are going to be the remainder. So what is that? 10.8. You could enter this as one unit too, because they're all molded together. So you could have 18.4 for the Halflight and 21.6 for the door. So either way. Good. Let's go back to our floor plan. Work our way around here. We'll get this done real quick here. I'm going to kind of speed things up here. 12.5 for the that window. We've got 2 more 3050s. 15, 15, and it looks like that's it for the front. On our left side, we've got let's see, 1, 2, 3 windows, and looks like a half-light or full-light door. So let's go ahead and take our windows here. Window is a 2036, that's 7 square feet. Window 2 is the same. Window 3 is a, what is that? 3030, right? Can you guys see that? Okay. So 3030, 9 square feet. And not sure what this door is here. Let's see if we have anything in the door schedule. That's door number 7. Door number 7 is doesn't say anything there. Let's take a look at our elevations. It's probably covered up by the garage, so we're probably not going to have anything there. Yeah, so I'm going to assume, since there's a note there and it says tempered, I'm going to have to assume that that's a full light door, a 3068 full light, and then I'm going to just flag it to ask the designer, hey, is this a half light, full light? I need some detail on this door. So I'm going to call that out as a French door, and I'm going to call it 20 square feet for that one. Good. Any questions so far? Am I moving too fast, too slow? All right, working our way to the back windows, 2036, that's 7.5 square feet. A 2640 is 10 square feet. You guys see where I'm at? I'm right here. Just moving my way across the back here. 2636. That would be 8.75. I'm going to call it an 8.8 square feet window. You could enter 8.75. That's fine. I'm just kind of rounding up to the nearest decimal point, kind of giving me the worst case scenario here. So looks like Bebo 210's got a question. I usually try to match the square footage shown on the construction document so it matches for the building department. Yeah, that's a good point. And that's really good to match that. Now, in some cases, there could be a discrepancy from what the designer has labeled the square footage and what the Energy Commission says is the conditioned floor area. So we'll get to that one when we get to the second floor, because there is a discrepancy there. We'll take a look at that. So let's see. Our next window is a 2650, so 12.5 square feet. I've got a patio door here, and it looks like it's a 6068. That's 40 square feet, and one more window on the back wall is a 2650, 12.5. Good. Moving right along, let's go to our right wall. A couple of 3050s, 15 square feet, 15 square feet, and 2 more. Cool. So far, we've got our first floor wall, a floor area, window area, wall area takeoff. One more thing that I need for a raised floor is that I need a perimeter around the first floor in order to show that it's a raised floor. So excuse me while I take a drink of coffee out of my Coden coffee mug. I will be giving away 1 or 2 of these. If those of you are very prolific at chat, have an opportunity to get one of these mugs shipped to you free. So just want to encourage people to ask questions, use the chat feature there. So rather than doing the perimeter feature around here, I'm just going to add up my dimensions. I know it's 60 by 32. And that gives me a total perimeter of 184 linear feet. You'll see where this gets entered once we get to the software here. Second floor. Now, if you remember, based on our section, that second floor is 8 feet. But what we want to do is take care of that little sectional wall that covers the floor. Now, you could have added this to the first floor. But if you remember, I added that little 6-inch piece of wall to the first floor. But so just so I'm consistent, I'm going to add that to the second floor. So technically, we've got a 9-foot wall here rather than an 8-foot wall. So we're just covering that little bit of envelope on the exterior surface. So that said, our top floor is 5 feet narrower than the bottom floor. So instead of 60 feet, we're 55 feet, but we got a 9-foot plate. That's gives me 495 square feet on the front and back. And the left and right is going to be, let's see, that's 32. times 9 gives me 288 square feet, left and right. Okay, let's go through our windows real quick. Window, I've got 3050, 15 square feet, 15. I've got a 2640, that's 10 square feet. You guys following along here, right here, and I'm moving over to the slider. 40 square feet for that 6068 slider, another 2640, and 2 more 3050s. I like to do my windows separately. You could total up all the area of all these windows and input, as long as the window performance values are the same, you can input it as one value. But I like to do them independently. There's some jurisdictions that require you to do them independently. That's their prerogative, and if so, just say thank you. I'll get you a revised CF1R shortly. So on our left wall, 3040, another 3040, another 3040. How nice. Very convenient to have these sizes all the same. I love the personal touch on whose bedroom this is. Patricia's office and guest bedroom. All right, back wall. We've got a 6068 slider, 40 square feet there. We've got 2 3040s by that tub, so 12. You could have grouped those together if you wanted. I just do them separately since they're called out separately. That water closet window is 2040, 8 square feet. And it looks like we got one more window here. Sorry about that. And another 6068. 40. Good. We've got our wall takeoffs. We've got our window takeoffs. One more thing that we need to do here. I mentioned earlier that we had a discrepancy. So my designer is calling out 1,558 square feet for the upstairs. My gut tells me that he's excluding the stairwell. Okay, and that's probably the case. So let's just go there real quick and just grab an area on this. I'm just doing this down and dirty, nothing fancy. So about 88 square feet, 1647. Yeah, we're within a foot. So, this is, something you might have a discussion with your designer. Technically speaking, the Energy Commission says that when you have stairs are counted twice. So the area below the stair is the first floor. The area of the stairs is the second floor. So in this case, I'm going to just stick with what the Energy Commission calls as conditioned floor area rather than deal with that. So looks like Michelle had a question. She says, yes, send a mug my way. All right, Michelle, I'm counting you in as doing lots of questions in the text or in the chat window. So Bebo 210 says, doing windows individually lets you do different overhangs also. Absolutely. That's the other benefit of doing windows individually, that you can enter the overhangs. Today we're not going to do that, but yeah, I would say that's a really good motivator for doing all the individual windows. So let's jump back downstairs, and I just want to get a little bit of area. I talked about there's a roof area over this first floor that's not doesn't carry up to the second floor. So we'll need to address some roof area on floor 1. That's a 5 foot by 20 foot area. So you can see here, dimension 5 feet, 20 feet there. So 100 square feet of roof. Now let's take a look at that roof. And I'm going to throw out a question here for you. What is the minimum roof ceiling insulation mandatory requirement for insulation in a roof? And you throw that out in the chat window. Let me know if you know what that is. All right, so here is a cross section through that utility room, kitchen. We've got 2x6 rafters. And you can see my designer says, Brian, what can we put in there for insulation? Can I put R19 bats in there? Anybody? Yeah, so I haven't seen anybody respond yet, but the chat window, or let's see, the minimum mandatory insulation value All right, yours ready for this? R22. R22, you go to section 150.0, you'll see that the minimum insulation value there. Am I going to be able to fit R22 in there? Maybe. If I went to like a rock wool or something, I might be able to get R23, but then I have some ventilation issues. Actually, Debbie, the mandatory insulation values does not depend on the climate zone. Mandatory insulation values are mandatory. You got to meet those. Now, you might have a prescriptive value for that, according to section 150.1, but 150.0 is mandatory. You got to meet those mandatories. So in this case, I'm probably not going to get a flexible bat in there. I'm going to suggest that we do a not rigid foam, or we could do rigid foam or a spray foam. Fill that cavity. Fill that cavity with insulation. We're going to fill it with at least R22. So that's the minimum mandatory right there. So cool. So just keep that in mind. We have 100 square feet of roof on the first floor. And I'll show you how to model that. Cool. And let's take a look at anything else. I didn't notice any skylights on the second floor, so we don't have to address skylights, which is cool. That's kind of nice. So we just have our just normal envelope stuff. We've got a vented attic roof with ceiling insulation, and the designer's chosen to go with below roof deck insulation. But you're going to see here that they've suggested instead of let's see, they're doing a comp roof. They're suggesting R15 instead of R18 below roof deck. So okay, we'll just give it a shot, see if that works. So the R18 without an airspace is the prescriptive requirement in climate zone 12. So in a lot of the hotter climate zones for below roof deck insulation. So so they want to see if they can get it to pass with a little bit less. You know, R15 is a 3.5 inch deep bat, and those top cords are most likely 3.5 inch deep top cords of the trusses, and it kind of works out real nice. They don't have any hangover there. So okay, well let's go to EnergyPro. I'm gonna do this. Let's just go from scratch here, rather than using the wizard. I think I've in one of our episodes used the wizard, you know, just to show you that. I like using the wizard just to get the basic information in, but today I'm going to do this via Scratch. I can't type today. 2-story code and coffee. All right. So it's a new building. I like to enter my front orientation. 46 degrees here. Now you could enter it as 0 and then come back and do a rotation. That's fine. My principal heating source, if you've ever been to Groveland, there's no natural gas available, so we're going with propane today. We're going to select the nearest weather station. That's the Sonora Ranger Station. That gives us climate zone 12. Good. Project information, I'm not going to worry about right now. Designer information, you guys know how to do that. But I want to go to this residential tab here for a second. We have a crawl space, so we need to enter a average height for that crawl space. And if you remember from our section, that crawl space slopes a little bit. Just for analyzing purposes, I'm going to say it's 2 feet average. So we're going to go with that for right now. And if you remember that perimeter measurement that I took, 184 linear feet, that's where we're going to enter our perimeter. Now, we have an option here to say whether or not we have ventilation cooling. Let's go back to our plans. And a little feature that I send to my clients is this energy features summary. And this is something that we do for the finished product, but a lot of my designers include it and make a suggestion of what they want to do. So they're planning to use a whole house fan. It's the Quiet Cool ES 6400. So it's roughly a 6400 CFM product. So I've looked that up on the appliance efficiency database. So we're going to input the actual numbers for that today. So good. Back to EnergyPro. So I'm going to say we're going to use a whole house fan. Now, if you're using CBEC Res, you can choose to use the default cooling ventilation whole house fan, or you can enter a specific one. EnergyPro, you only have a choice of using a the whole house fan and entering the actual values for that. So, all right. Well, that's all general information. Let's add a plant, and under that plant, add a system. We're going to come back and tackle our mechanical and hot water later. I want to add a zone here. Now, the designer communicated to me that they've got two systems. One split system for the first floor and one split system for the second floor. Each is serving those respective areas. So we're going to end up with two systems here today. It's kind of unique. We haven't done that before. And each system is going to serve its respective zone. So we're going to start with the first floor. This is a user input. Call it anything you want. It's condition. It's a single family. I want to set my building story. So we know our ceiling height is 9 feet. Elevation above grade. This is relative to our average crawl space height. Our floor-to-floor height, we know that is 1 foot higher than the ceiling. So my floor-to-floor height is 10 feet. I'm going to leave my window height there at 6.7 or 6'8". While I'm here, I'm going to go ahead and set my the information for my second floor, but make sure I don't select the second floor for the first floor height, because that's going to give me an error. Ceiling height is 8 feet. Elevation above grade. So we're going to add the crawl space, so 2 feet. We're going to add the 10 feet floor to floor height, right? So is that right? 10, 11, 12 feet, right? Elevation above grade. Floor to floor height for my second floor is 9. So yeah. Everybody good to go so far? I almost selected floor 2 for my floor 1 zone. While I'm here, I'm going to select my dwelling tab. Let's take a look at how many bedrooms are on the first floor. I think there's only 1 bedroom. And why is that important? Anybody? Type in the chat window. What is the note on the whole house fan about making it the first zone? Oh, yeah. True. You're right. Thank you for that. I am going to select that whole house fan on the upstairs zone because it's relative to attic of that floor upstairs. So we'll get to that when we get to the mechanical section here. But at the building level, I'm just identifying that we have a whole house fan. So, okay. Why do we need the number of bedrooms in the zone? Somebody hit me up in the chat window about that. Why is that important? I like to remove these appliances. Doesn't hurt anything. So lower floor, I'm going to add the room. So my room is my zone, right? And we know that's 1,747 square feet. From here, I'm just going to start dumping in some opaque surfaces, right? I know I have a roof. I know I have 4 walls. And I have a raised floor, right? So that's going to define my first floor. Let's go ahead and start entering information here. I know I have 100 square feet of roof area. Sharon says ventilation. Absolutely right. Indoor air quality ventilation is the reason we want to enter the number of bedrooms. Square footage and number of bedrooms are the 2 factors needed for determining what the ventilation rate is. And BIBO 210, exactly. The number of bedrooms identifies the number of occupants in the building. So it's a number of bedrooms plus 1 is part of the factor there. So, all right, so we have a new roof. This roof assembly is going to be a rafter roof, okay? So I'm going to pick one of these defaults here and duplicate it. So this is the R19 roof, no attic. I'm going to call this R22 rafter. Okay, I'm going to come in here on the Res Performance tab, and I'm going to say that cavity insulation. Now, they're going to have to go to a spray foam in here. Now, the software doesn't say what type of insulation. It just says the cavities are 22. The framing type is 2x6, 24 inches on center. We don't have any above roof deck insulation, no below roof deck insulation. That's it. That's how you would model it. Now, you may need to do non-standard spray foam insulation requiring QII. If you chose QII, that might be a necessity. For this case, we're just going to run it as R22 cavity with a 2x6, 24 inches on center. Now, this does have an orientation. That wall or that roof faces the left side. We know that orientation is 136 degrees, but what's our angle? What's our pitch to that roof? It is a 4 and 12. It's easy just to come in here and just use an angle calculator. You guys might know what this is right offhand. 18.4 degrees. Cool. Everything going okay so far? So I'm going to enter 134 degrees, my orientation. The slope of that rafter is going to be, what's it, 18.4? Cool. We're done with that roof. Let's go on to our front wall. I like to label these just the way they are. Front wall, my area is 570 square feet. We know it's an R21 wall, because that's what the section said. The orientation of that wall is 46 degrees. Okay, we're going to do our walls and come back and do all of our windows. So left wall, I just like to make sure that these are all done before I move on. 304 square feet, R21 wall. Orientation is 136. Great. Moving right along. Anybody have any interesting projects they're working on? What's the largest house, the largest square footage house you've done, analyzed? Let's hear it. I want to see. Maybe the biggest house gets a Code and Coffee mug. How's that? And this is my right wall. Areas. 304. Did I get that one right? Yep. 304. R21. Cool. Orientation. 316. Sharon says 6,000 square feet. Can anybody top 6,000 square feet? Do I hear 7,000? 6 going on 7. 65. Well, we like to keep this fun. Keep it light and fun, right? This is more of a show than a formal training here. So you guys get to look over my shoulder and see what I do, and I get to talk and do my work with people watching. So kind of fun. All right, we entered our floor. So Bebo 210, I do a lot of small garage conversions. They are giant pain to get. Yeah, the smaller the building, usually the more difficulty it is to get it to comply. Couple things that I like to do just to save time. I know my front left, rear, right wall are pretty much all the same. I'm gonna come in here and copy, paste, and copy. Oh, that's why. Add room. It's just a time saver. We can enter them just like we did with the first floor, but I just like to save some time and just go back in and change the areas. Let's go back to this, select building floor 2 for my upstairs zone. dwellings, number of bedrooms. Let's take a look at our floor plan. Did anybody pick up on that, what the number of bedrooms were? I think there's 3. So yeah, 1, 2, 3. Definition of a bedroom, it has a closet in it. So no matter what they call it, they could call it, an office, but it's got a closet in there. It's a bedroom. So 3 bedrooms. Turn these appliances off. You can leave them on. I just prefer to turn them off. So upper floor. So I'm going to come in here and copy all these, paste all. Oh, I have to copy each one. Paste. See, all I'm doing is just copy, paste. I like to save time. Anybody like to spend a lot of time on stuff? Not too many people do. So I'm going to add an interior surface because we need to connect these 2 floors together. Okay, so let's go back, and now that I got all my, let me go to the second floor. I'm going to change these areas. So the second floor is 495 square feet. Same R21. Left wall is 288. 288. Rear wall 495. Right wall is 288. Our roof is going to be the same as our floor, 1647. Now remember, they're doing an R38 attic roof with R15, right? So I'm just going to take this R38 attic roof, I'm going to duplicate it, and I'm going to do R38 plus R15. Again, this is a user input. This is the way I do it. You can label it any way you like. So I've got R38 in the ceiling, and I have R15 below roof deck. Now the insulation does not cover the underside of insulation framing at underside roof deck, because that insulation does not continue beyond that 3.5 inch area. So that's it. And we don't have a raised heel, so this is pretty much as it's going to be. The orientation for an attic, a vented attic roof, is the same as the front orientation, and you got to enter a slope here. Oh, I think I messed up on that other one. I entered degrees, instead of slope. So 6 and 12 there, 4 and 12 in the other. So I need to go. Nobody caught that. I'm surprised, you guys. Yeah. Oh, Sharon. Yeah, they did put 18.5 instead of 4 and 12. So I'm going to go back and fix that. So this is a 6 and 12 roof. The roof on the first floor is a 4 and 12 roof. I don't know. Maybe I was thinking Seebeck Res does it that way. So as degrees, I may be wrong. It's been a while. So good. Interior surface. Let's connect those 2 floors. Now, if I'm dealing with a 2-story house, let's talk about this for a second. I like to make the interior surface relative from the zone you're in to the zone below it. Now, you could put an interior surface as a ceiling in the lower floor relative or adjacent to the upper floor. I don't like to do it that way. I like to do it as a floor adjacent to the zone below. So in this case, we have a zone of 1,647 square feet. Now this is an interior surface. There's no insulation in this. So I like to sort these by type and go to a floor and look for R0 floor, no crawl space. That's just what I use there. Now, the floor elevation is important because this floor is, we have our crawl space of 2 feet, our floor to floor height of 10 feet. That floor elevation relative to the zone is 12 feet. So, and then I'm going to say it's adjacent to the lower floor. So that's how I like to do it. You can choose to do it from the lower floor to the upper floor. Keep in mind, though, that floor elevation, if you're putting in a ceiling of the first floor relative to the second floor, the floor elevation is relative to the zone. So you would enter 2 feet as the floor elevation. So keep that in mind. So Bebo210 says, will it make a difference in the program doing it that way? Slightly, because what happens is instead of choosing a floor assembly, you need to choose a roof assembly. And there's a slight difference. The software calculates it differently. So technically, to me, that's not a ceiling, it's a floor. It just depends on which room you're in or which floor you're on, to make it relative. So slightly difference. If you run the analysis, you're going to see that the proposed design will change slightly. So another shameless plug for our EnergyCode Ace Code and Coffee mugs. So we got a lot of people chatting, so that's awesome. Love it. Let's go back and put all of our windows in. I'm going to blast these out. I'm going to do these pretty quick. I've got my residential prescriptive fenestration already in on my default. So that's a 0.32 U factor, 0.25 SHGC. When we get to those Halflights and French doors, I'll show you what I do there because I don't know what those values are. I need to coordinate that with a designer. So in the meantime, I'm going to use a default value for that. So window number 1 was 15 square feet. I'm going to do my over-the-shoulder shot here. You guys can kind of see what I do here. So you can see I've got my takeoff here. It's a mess, I know. I've been doing this really fast, but it works. Window number 2, 15 square feet. Now you could copy and paste these windows just like I did the walls, however you like to do it. Sometimes if I have a lot of the same window, I do it that way. So this is my Halflight door. This is, I'm going to group these together, 18.4 square feet just to save some time. It's not my residential prescriptive requirement, right? So technically this is a double non-metal clear, but it's going to be a door instead of a fixed or operable window. So I'm going to come in here and copy that, call it a double non-metal clear door. I'm going to indicate the fenestration type as a door. Number of panes are 2, and it is operable. That door opens and closes. So I'm going to hit OK. Wait, I'm going to change this to manufactured because it's not a site built. Good. What that does is it looks up table 110.6 A and B and says, okay, based on the criteria you said, this is the default value for it. So that's my worst case scenario, is that it's a default value. So my front doors are 21.6. Let me go back to my inputs. That way you guys can follow along there. It is a wood door. I'm just going to stick with that there. Let's keep going, add more windows. How are we doing on time, guys? It's taking a lot of time for this. Okay, I'm just going to blast this out. So if you have questions, slow me down. If I make a mistake, call me out. See what I did there? Copied a window I already had, 12.5 and 2 15s. Copy, paste, copy, paste. Good. Left wall, add window. 12 square feet. We got 3 of those. Actually, no, that one's 7 square feet. Sorry. 7. We got copy 2 of those. Add window. This can be really fast if you do your takeoffs right. It's just data entry at that point. I'm going to grab my Halflight door value for that French door. And call that's that door going out of the kitchen, going towards the garage. So again, I don't know what that door is, so I'm going to use the default value for a double non-metal, which is a wood door in this case. Okay, rear, we got a bunch of windows on the rear wall here, so I'm just going to bang these out. This just takes time. We need the fast forward in the video at this point. Anybody have any good questions that I can answer while I'm entering this stuff? Come on, we still got some time on the clock to work towards that Code and Coffee mug. On 8, another 12.5 square foot window. Now, you might have a designer that has all the performance values. Your fixed windows may be different than your operable windows, than from your sliding glass doors. They might have, various, different values here. But, if they do, sometimes I'll just take a worst case scenario. Take the worst one. Does it comply with all of the windows using the worst value? Sometimes I've had to add a specific value for like 10 or 15 different types of windows. So it just takes a lot longer. So assessing a project up front is important to know what you're getting at, know what you're getting into. So I'm up on the second floor now, just adding windows here. This is the monotonous part. So let's add another window, 10 square feet there. Now you could also go in here and custom tailor each of these windows to match what's on the window schedule. So that, I've had just some jurisdictions actually ask me to input the windows. Let's see, what am I at? I'm losing my spot. 15, 15, 10. I got the 40. This is a 10 square footer. I see Bebo 210. I saw your question there. I'll get to it in just a second here. Copy, paste, copy, paste. Good. So Bebo 210, is that table on the plan something you added? Yes, that is something I added. If you want a copy of that, it's a spreadsheet. Email me at AceTV@energycodeace.com, and I'd be happy to email that one to you. So just a simple spreadsheet I put together. I share it with a lot of people. So I find that it helps communicate to the client what the requirements are in plain English. Something that they can understand, that is in their language, deals directly with terms that they know and can interpret. So, and they don't have to search for it all over the place on the CF1R. So another 12 square footer. Am I going too fast for anybody? I know this is like, if you're not into modeling or doing Title 24 compliance work, I'd be really bored right now. Maybe you are bored. I hope you're not bored. So thank you guys for tuning in. Just about done with our windows here. I got a bunch of 15 square footers on the right. Almost done. Copy, paste, copy, paste, copy, paste. Done. Look at that. Record time. All right. Everything else is done on our opaque surfaces. We've got to define our HVAC system. Let's do a quick glance. They were nice enough to input what they're using on here. So gas furnace, 95 AFUE gas furnace, and just a standard 14 SEER 12.2 EER. So it looks like the ducts for the upstairs are in the attic. The ducts for the downstairs are in the crawl space. At least that's how I'm going to do it right now. So there are some requirements there that might be viewed by the inspector that might change that. So let's do HVAC system 1. System 1. I'm going to go in here and just add. Let's see. I'm just going to pick one here. So I'm just going to go like this. I'm going to go 95% AFUE 14 14 SEER, 12.2 EER. Oops, 12.2. So come in here. It's a split DX gas furnace. I don't know what the BTU output it is yet, so that is unknown. I'll have to go back in and ask. Not a big deal for it, just to determine the load factors. I want to say this is about 2.5 tons per floor, just from my experience. My sensible load is about 70% of that, so about 21,000 BTUs per hour, roughly 14 SEER, 12.2 EER. Okay, the IEER, integrated ER, doesn't do anything for non-res. Distribution, first floor. Those ducts are going to be in the crawl space. We don't have a whole house fan on the first floor. It's actually on the second floor. So let's go ahead and do our second floor system. HVAC system. System 2. I'm going to run a little bit over 11 o'clock. So hopefully that's not a problem for anybody. Same system for the second floor. Now, you could run one system that serves both floors. No problem with that. That occurs a lot. Now, we're not, even though somebody might choose a strategy for zoning that, having two thermostats, if it doesn't meet the criteria for zonal control credit, you don't run a zonal control on it. They just can't use a bypass duct in order to do their zonal control. So issues there with the HERS rater. So in this case, the distribution is going to be done in the attic. It's going to be R8. Here's where we're going to enter our ventilation cooling requirement. I am going to bring up, let's see, I looked this up on the Energy Commission's database ahead of time. So here is our, let's see, where is it? Quiet Cool 6400 right there. Right, so we have 5,142 CFM, and the motor is drawing 623 watts. Cool. That's pretty easy. Let's go ahead and, oh, I just forgot what it said. I want to move this to my other screen just so I can look at it. So I'm going to enter my CFM value of, what did I say? Ooh, no, that was the wrong one. Did you guys catch that? I want, there's two Quiet Cool 6400s. I want this one, the 5070 and 537. So, do you have any questions? 537. I can't see my chat window, so I don't know if I have any questions. Good. Nothing. So, okay. Doesn't look like there's any questions. Good. One thing I do want to add, though, I want to add verified refrigerant charge to this, and I need to do that on both systems. So on the HERS tab, airflow and fan efficacy is mandatory. Duct leakage is mandatory. You don't need to worry about that. So one last feature to input before we analyze this thing is our hot water heater. Hot water heater. How about our water heater? That's kind of an oxymoron, hot water heater. We've got a gas tankless 0.96 EF, not a UEF, but a 96 EF. So let's go back and put that in. I don't really care about model number at this point. Now, as I'm inputting this, I might have to go back and change this depending on the type of water heater they put in order to get this CF2R finished. Currently, the way the registries work, if you don't have the right BTU output or input rating, it doesn't work. So I'm going to use the 199,000 BTUs. Change this to point. I said 96, right? So Bebo 210, do you have generic input for a whole house fan? Yeah, it's 1.5 CFM per square foot of floor area. And that would be the CFM fan flow. The wattage, I'd have to look at the ACM reference manual to see how they're calculating the wattage here for standard. It's not something that they make. It's not in the standards. It's not in the manuals, the reference manual, or the compliance manual. I think it's buried somewhere in the ACM. So good. It looks like I'm done. Let's go ahead and analyze this thing. While that's going on, let me just go over the shoulder shot here. Now, through the magic of YouTube here, we're going to run this analysis and bring in my system crashes because I'm running 2 cameras and streaming live to YouTube. So let's go ahead and run this CF1R and see what we come up with. Before I display this on the screen, oh, I already did. I was going to say, anybody take any guesses whether it complies or not? So you can see that already there. It complies. Our compliance margin is 0.96, or the percent improvement is 1.5% better than standard. That's a little close for my comfort level. So in this case, I'd probably go in and factor in all the overhangs. That isn't going to cause the client or the occupant any more expense. They already have those overhangs there. I know by doing that, at least on the east, south, and west face, that it's going to make an impact. So I'll probably take the time to go through and do that. That's going to give me a little bit more comfort level when I'm dealing with compliance. If there are any issues when they go to install things like, oh, we added some skylights, does it still comply? Or we added skylights and the building inspector said we need to rerun the CF1R, and now I go, oh great, it doesn't comply at a 1.5% compliance margin. So in that case, I like to have a little more comfort level. So some people, when you get to that point, they might say, just make it comply. Give me the bare minimum. Great. Other people are, we're doing all this stuff. We want to make sure that we're saving energy. Now, TDV energy use is not site energy use, but it's relative, right? So if we're 20% better than standard on our TDV energy use compared to something that's 1.5%, you're going to save a lot of site energy, and that relates to lower utility bills in theory. Now, there are no behavioral factors in this, so this is just straight analysis. So, all right, I did it. An hour. Ran this simulation, did our takeoffs, did the inputs in an hour. That's the biggest project I've done on a live show in 1 hour. So, yay. That's it for today's. Now, just a quick overview of the CF1R, just to make sure we modeled this right. Climate Zone 12, 3,394 square feet. That's a good size house. 2 stories. Number of zones, 2. It complies. Let's see. I'm just going to move on down here. We've got a whole house fan. This cracks me up. Floor has high level insulation. It meets the minimum mandatory and prescriptive value. That's funny. Ducts and crawl space, central parallel. That is not right. How do we get central parallel piping? That might be something that I need to go back in and look. Maybe if I rerun that without that, we might see something else. Indoor air quality, these are all HERS features. These are all mandatory. Airflow, high SEER, or high EER verification, refrigerant charges is prescriptively required. We chose to do it. Fan efficacy, that's required. Duct sealing is required. So good. We can go through each of these tables here, but just quick glance. We looks like we input things correctly. I got our attic. We got no cool roof, no radiant barrier. Look at all those windows. Lots of windows. And if we added overhangs, we'd have more tables there. Bibo water heater. What's that?